Hi boys and girls, welcome back to the 3rd and 4th grade science club. I hope you guys are doing well. We're doing great over here and I'm very excited to be coming back to YouTube to see you and teach you some more science stuff. Are you guys ready? Okay. Well, like always, we're going to start with our vocabulary. And so here's our vocabulary. And again, feel free to pause the program if you need more time. Okay, so our words today, we're talking about tidal energy today. Our words today are tides and tidal energy. Tides. Tides is the rise and fall of the ocean based on the pull of the moon. So it's the gravity of the moon that pulls the ocean. So the tides rise and fall. I don't know if you've ever been at the beach and you build a beautiful sandcastle and you kind of walk away, maybe go have lunch, or maybe swim a little bit, and you come back and man, that ocean's getting pretty close to your sandcastle. And then you might go a little further away and do something else, and then you come back and oh my goodness, the ocean just totally swallowed up your sandcastle. Sometimes that happens. And that's the tide that's coming in. So the tides is the rise and the fall of the ocean. And you may have experienced that being at the beach at some time. Tidal energy takes that rise and fall of the tides. It converts it. That's a fancy word for changes. It converts the tides of the ocean into electricity. How in the world can we get the rise and the fall of the ocean and turn that into electricity? Well, I'm going to tell you today. Today is your lucky day. Today, we're going to find out how that happens. Are you ready? I am so ready. Okay, all right, so those are our words for today, tides and tidal energy. Okay, and we're going to start with our Bible verse. So here's our Bible verse. Go ahead and glue it into your notebook. Find your page. It should be after your Earth's Resource title page. Should be where your Bible verses are. Go ahead and turn there. Pause the program if you need a little more time to cut and glue. Okay, let's read our Bible verse. I'm going to put it flat so I can at least read it upside down. My cameraman is zooming in. So follow along with me. Should you not fear me, declares the Lord? Should you not tremble in my presence? I made the sand a boundary for the sea, an everlasting barrier it cannot cross. The waves may roll, but they cannot prevail. They may roar, but they cannot cross it. Jeremiah 5:22. Okay, so who is talking here? It tells us in the verse who is talking. It's the Lord. The Lord is talking, and he said, should you not fear me? And boys and girls, there's a lot of debate about what fearing the Lord means. And this is how I think of it. I think of police officers, right? And police officers are good. And if I'm in trouble, I want a police officer there with me, right? But if I get in trouble, if I run a red light, and like that means driving through a red light, and there's a police officer there, I'm a little scared that, oh no, is he going to pull me over because I broke the law, right? So that's kind of how I think about what fearing the Lord is like. If I need him, he is there for me, and he is who I run to. And he cares about me, and he sent his son Jesus to die for me. But if I do wrong, I'm scared because I know God is big and powerful, and he sees the wrong I do. And there are consequences for the things I do. And so here in Jeremiah, God is talking to his people who have done some terrible, terrible things. And he is saying, you should be afraid. You should tremble in my presence. And this is why. And this is really cool. And this is why I picked this verse as we're talking about tidal energy. He says, I made the sand a boundary for the sea. an everlasting barrier it cannot cross. The waves may roll, but they can't prevail. They may roar, but they can't cross it. God is so powerful that he made the boundaries of the ocean. The person who made the boundaries of the ocean, if he says that I shouldn't lie, then I should be scared if I lie, right? So he is a big, powerful, strong God, and we should listen. And guys, the rules that God has for us, it's because he loves us. It's like your parents saying, don't run out into the street when there's a car. They don't tell you that because they want to be mean and keep you from being free. They tell you that because they want to protect you. And that's the same thing with God. He has rules for us and they're there to protect us. And we should listen. And if we don't, we should be scared because he's a big, powerful, strong God, right? And so I think this verse is really cool because he set the boundaries of the ocean. He set where they can be and where they can't be. And it's really cool with tides because they come up a certain level and then they go out a certain level. And it's always the same. And scientists have studied this and they know what those boundaries are. So that's a pretty cool thing. We have a cool, awesome God that we serve. Okay, boys and girls, that's our verse. Make sure it's glued into your science notebook. All right, so let's talk a little bit about how tides came to be. How is it that we have tides? And so I have my blow up earth. I got it at the dollar store and it leaks. I just blew it up and look, it's already starting to sag, but that's okay. So here's our earth, the model of our earth. It's not the actual earth, right? We're on the earth. I can't hold the actual earth, right? But it's a model of the earth. And here we are. Look, it even says Houston. We live right outside of there. You see Houston? Can you see it, cameraman? Cool. Okay, so there we are, and this big giant earth. And I'm going to use this tennis ball to represent the moon. And it's kind of bright and glowy, kind of like our moon is at night. But the moon does not make its own light. It reflects the light of the sun. So the sun the light of the sun comes and it hits the earth, hits the moon, and that light gets reflected back to the earth. Okay, so that's why we can see the moon and it seems like it's glowing, but it's not glowing. Okay, I almost lost the earth there. Oh, okay, and the earth is tilted on its axis. That's how we get seasons, the tilt of the earth. And the moon revolves around the earth. And as it's revolving around the earth is also rotating, okay? Actually, I think it's this way. Ah, I lost the earth again. The earth is rotating as the moon revolves around it. It's a little tricky. If we were doing this in class, I would actually get students to do this, and you guys might get a little dizzy. Okay, so the moon is about like right here. The earth, I'm gonna just put it down and spin it because I think that'll be easier. The earth spins one time and then the moon starts to move a little bit, okay? And so it takes about a month, I think it's like 28.5 days, don't quote me on that, I think it's something like that, for the moon to go all around, to revolve all the way around the earth, okay? So the earth has to spin about 28 times for the moon to go all the way around. So in one day, it doesn't seem like the moon is moving very much. It seems like it's pretty much in the same spot. So I'm gonna use Houston, us, as an example. We'll use Galveston because that's like the most familiar beach. And I know some people don't love Galveston, but you know why I love Galveston? Because it's the beach closest to us and it's the beach I've been to the most times. And I've lived in Houston my whole life. And if my parents were taking me to the beach, it was Galveston. And yes, it's not beautiful and wonderful, but it's an ocean, y'all. We live in a place, we can drive to the ocean. Okay, so enough about that. And Sylvie's rant about how you should love Galveston. You don't have to love it. Anyway, okay. So the moon is here, and when it's here like this, the gravity is pulling, okay? And I can actually like squish my ball a little bit. The gravity of the moon is pulling the water this way. So what you're gonna have is on this side of the earth and this side of the earth, you're gonna have high tide. You're gonna have more water coming in to the earth, okay, because of the pull of the moon. And then as the day goes on, okay, now you're here. The oceans here are now being pulled this way, okay? So you have high tide here and high tide here, but now you have low tide here and you have low tide over here. And then as the earth spins another 6 hours, you're gonna have high tide here and high tide over here. And this is where Galveston is over here. So we're gonna have high tide over by us and low tide on this side and low tide over here in China. Is that China? That's China. Okay. And then the earth is gonna spin another 6 hours and we're about where we started. And the moon is gonna be a little further. And again, you have high tide here, low tide, low tide. I hope that helps you understand a little bit better. Do you think you understand a little bit better? Okay, all right. So if you were in class, I could read your sweet faces and I could see either confusion like this on your sweet faces or like understanding on your faces. But unfortunately, I can't do that via YouTube. So anyway, that is how we have the tides. It's from the gravitational pull of the moon. The gravity of the moon pulls the ocean towards it and on the opposite side. Okay, so that's how we have tides. Now that we know how we have tides, let's figure out how we can possibly turn that into electricity. How can we use that to power our homes? How is that possible? It's a little mind-boggling. So you should have this little sheet, right, like this, and it has a cute little contraption on it. And I'm gonna tell you, I did some Googling, and not all of them have this like whole setup like this. So we'll talk through, and then we'll talk about what might be limiting. So go ahead and glue this into your notebook. Pause the program if you need more time to glue. Okay, so here we go. Let's talk about this. So here we have, okay, we're gonna start having high tide. So this water is going to come from there through this little opening and come out. And as it comes through, it spins this little propeller. Now that should make you think about wind energy, right? When we have spinning, then what we have is we have rotation of a magnet and wire together, and that creates electricity, okay? And then if we have, oh, I think my ball just fell, that's okay. And then what happens is the tide goes out, because now it's low tide, and it comes back through the same opening, and it spins a little propeller again, and then that has a magnet and wire, and then that creates electricity. Okay, so let's read this. The best way to capture tidal energy is to place the turbine, that's this little part that spins, in a narrow opening. When the tide comes in, the water rises on one side of the opening and pours through the opening to the other side. When the tide goes out, the water on the higher side pours back through the opening where the water level has dropped. This same thing can also happen where they build dams, like the Hoover Dam. It's a huge dam, and it stops the water, and they can open the opening for the water to be able to go through, and then it spins the turbine, and then there's wires and a magnet, and that creates electricity. And so they can use those dams by opening and closing it to be able to create electricity. So it's kind of the same thing as tidal energy. You know, you have the water coming and spinning and coming back out. Okay, so that is how we can get energy from tides. All right, now, oh y'all, I forgot. It seems just like being in the classroom. we need to check our compost column, right? Before I get into too many experiments, let's go ahead and check our compost column. Let's see how we're doing. Do we have, oh, now our rot is not looking so rotten anymore. It's starting to look like dirt, isn't it? Wouldn't you say? Oh, I have a little bug. I have bugs. Uh-oh, this thing might go outside because I have a lot of bugs in there. Do you see all the bugs? Ew, this is going outside after this. Okay, so let's see what our temperature is. Yuck, I hope you don't have bugs in yours. Our temperature is 45 degrees Celsius. Oh, 45 degrees Celsius. Can you see that? Yes, we have like fruit flies all in here. They're very excited. Oh gosh, yuck. Ellie, can you wait just a minute? I'm gonna have you take this outside. Oh. You have 25 or no? Yes, 25 degrees Celsius. And boys and girls, I'm gonna give this a little shake. Actually, no, we're gonna take this outside. Okay. My daughter's here and she is going to take it outside. Thank you, Ella. Yay. It's gonna leave the house. So we don't have bugs inside our house. Okay, our cat likes to run outside. Go quick, go quick, quick, quick. I think she's sleeping somewhere. Okay, all right, bugs are gone. I better not. All right, so we want to write that here on our list. Now I will say bugs are good decomposers and they do help break things down. So I'm not surprised that there are bugs in there, but I don't want them in my house. So out it goes. And we will look at the temperature next week. So I will put it like in a covered area. And I might switch out the aluminum foil for saran wrap so that it's a little bit more secure and then put a rubber band around it. But I don't want it in my house anymore, guys. Mr. Sylvie is behind the camera shaking his head no. He does not want it in the house either. Okay, all right, so if you guys did this at home, I don't know what situation you're in, but you may not want this in your home anymore as well. All right, so I'm gonna write on here, day 14, 25 degrees Celsius. Now that we have it outside, I'm not gonna be surprised if our temperature is gonna change significantly to match the outdoor temperature. This is our indoor temperature and it's been pretty stable. It's our indoor temperature, and then now that it's outside, it's gonna have a different outdoor temperature. It's been pretty moderate, the weather. In fact, we've been eating outside a lot and just kind of having, Mr. Sylvie and I have coffee outside in the morning. That's nice. We should do that tomorrow morning. And it's just been a really pretty time to be outside. And so I don't think this temperature is going to get super higher, but I do expect it to increase since I've just moved it outside. So those are our temperatures there. And I hope you've recorded that. If you need more time to record that, it should be in your notebook. Feel free to pause so that you can write that in your notebook. Okay, all right, we got our compost column taken care of. And next, we are going to work on our tidal energy. These are the pages that you should have. It's just those 3 pages. Okay, we're going to be using these 3 pages right now. Tidal energy. They're the ones that have the borders that are swirly. Okay, those are the ones that you need, the pages you need. Okay, here we go. All right, so here's our problem. I'm going to move these other 2 to the side. Which amount of water will create the most energy? These are our materials. A paint pan, and I actually have an aluminum pan for that. A 2-liter bottle, a ruler, push pin, water, pitcher, funnel, pinwheel, and tape. Now, this I did not tell your mom to get you all these materials because I'm going to demonstrate this. And even if we were in the class, I would do this as a demonstration, okay? Because it's kind of precise in how you do it. But it's kind of, still want you to be able to see it. Okay. Your teacher will poke a hole in the bottle at the 5 centimeter mark. Your teacher will fill the bottle to the 10 centimeter mark, and you will record the distance the water flowed from the hole. Your teacher will repeat the test at the 15 centimeter mark and the 20 centimeter mark. If we fill the water to 20 centimeters, 15 centimeters, and 10 centimeters, then the water will flow the furthest from the pinhole when the water is at the blank mark. I feel like this might be a little confusing without seeing it. So I'm going to get it all set up, and then we will do our hypothesis, and then we will actually do the experiment part, okay? So this is what we're going to fill, and we need to make some marks, right? Because it talks about different marks. We're going to use centimeters, and those are our smaller units right here, right? See the little cm? It's tiny. Can you see it on there, Mr. Cameraman? Yep. So these marks are tiny, right? The bigger ones are inches, the smaller ones are centimeters, and we use centimeters in science. Oh, my cat sees a bird, so she's making chirping sounds. Y'all hear her? Okay. Yeah, she's very excited. Is that a bird? Could be a squirrel. Okay, so if you can see here, I am going to make a mark at the 5 centimeter mark, and then it says at the 10 centimeter mark. I hear crows, so I think she sees birds. 15 centimeter mark, and at the 20 centimeter mark. Okay, so those are our different marks. And then I'm gonna put a hole pinhole at the 5 centimeter mark. We want a pretty good size hole. I think that's big enough. We'll find out. If it's not big enough, I have screws that I can do, but I think this will be big enough. Yeah, I think that's good. Okay. So now what we're gonna do is, and I'll show you what we're gonna do without giving everything away. We're going to fill, I'm gonna put a little piece of tape over that pinhole, like that. And then we're gonna fill it to the 10 centimeter and see how far it comes out, that hole. And we're gonna fill it up to the 15 centimeter and see how far the water comes out the hole. And at the 20 centimeter mark and see how far it comes out of the hole. Okay, does that make sense? Okay, so so now that you can see how the setup is gonna look, I want you to go ahead and make a hypothesis. Which of these marks, that if I fill it up to 10 centimeters, you know what, let me write on here. 15 centimeters, 20. Which one of these marks that I've written on here, if I fill it to 10 centimeters, do you think it will go the furthest? If I fill it to 15 centimeters, do you think it will go the furthest? Or if I fill it to 20 centimeters, do you think the water will pour out the furthest? So which one of these marks, and that's your hypothesis. So it says, if we fill the water to 20 centimeters, 15 centimeters, and 10 centimeters, then water will flow the furthest from the pinhole when the water is at the blank mark. So you're gonna write 10 centimeters, 20 centimeters, or 15 centimeters in that spot. So go ahead and pause the program to write down your hypothesis. Okay, let's get started. And you're gonna need this sheet because we're gonna fill this in because we are going to measure how far the water pours. And I can't remember offhand how far it goes. So trying to think how I want to do this so that like I'm catching it in here, but it's still kind of, let me see, this is color. Oh, I think that will work. What do we think? That will probably work, right? Okay, so I have that sealed up, and now I'm gonna take the funnel, and I'm gonna fill it up to the 10 centimeter mark. Okay, we have the 10 centimeter mark? Yep. Okay, now what I'm going to do is I'm going to always measure in centimeters, right? We want to know the distance. Uh-oh, I got a little knot in my. Now this paint pan this pan might not be long enough, so I'm gonna just kind of swoosh all my stuff over a little bit, just in case I need to move it, and just if things get wet, that's gonna have to just be okay, right, Mr. Silly? Okay, I got the nod. We have understanding from Mr. Silly. You know what? I might tape this on here. What do y'all think about that? Seems like a good idea. So I can see my measurement. All right. I can't imagine it going much further than 35 centimeters. I have a feeling we're going to be able to catch it and cover my inches. Pull it tighter. Like that. Okay, all right. Here we go. Ready? Oh, I think that is right at 3 centimeters, and I'm going to seal that back up. So for the first trial, for the first trial, we have 3 centimeters. Right? Okay. And we want to do it again because good scientists do multiple trials. So now I'm going to unseal it. Let's see how far it goes. Oh, I think that looks like, what, 2.5? Okay, so I'm gonna write 2.5 centimeters. That's our 2.5, okay? 2.5. And one more time. Ready, set. It's getting weaker and weaker. I think that's 2.5. We think that's 2.5? Oh, on the camera it looks even further, huh? Okay, I think 2.5 for that one. So here I'm gonna write 2.5 centimeters. Okay, let's fill this up to 15. Oh, I need my funnel. That wouldn't have been pretty. Hey, get down. I have a very curious kitty here. She says, what are you doing? Oh, it might be a little too high. It's okay. We're going with it. Oh, I gotta look for my cameraman. Is that bad? I need to fix it? My cameraman is giving me looks like I am doing bad science. All right, cameraman. Yes, okay, I gotta smile. Here we go. All right, let's see how far it goes. Ooh, I think if we look right here, that's at 5 centimeters. Yes? Or should we look at the distance, the furthest distance it's going? Then that would change how we did all the rest of it, right? Where it crosses, how far it goes. How are we doing this? I need where it crosses. So 5 centimeters. 5 centimeters. Okay, let me seal that back up. All right. Hey, get down. Get down. Okay, 5 centimeters. Okay, and now I need to fill it back up because Mr. Sylvie thinks we should be right on the money. Tell me when. Okay, I think that's pretty good. Okay, ready? Set. Okay, where is it crossing? It's crossing at 5 centimeters again. Okay, seal that back up. Okay, all right, one more time. We still at 15 centimeters? We are. And maybe that one is 6 centimeters? What are we thinking? Maybe 6 centimeters for that one? Okay. All right, 6 centimeters for that one. Okay. All right. Yes? Okay, so now let's fill it to 20 centimeters. Oh, it keeps pouring, so I better. One more. Okay, here we go. Ready? Let me pull this tighter. It's kind of came undone. And we're looking at where this crosses, because remember this is a little elevated. We're looking at where this crosses the line, okay? So ready, set, go. Oh, it's crossing the line at 11 centimeters. 11 centimeters. I'm gonna write that here. 11 centimeters. Let me put this. See, wrote that there. 11 centimeters. Okay. And here we go. Are we still at 20 centimeters on the? I think so. Oh, ah. It's getting wet, so it's not as sticky as it was. I'm gonna get a different piece of tape out. Okay. And then I'm gonna do a piece of tape going this way. Okay. Ready, set. Oh, uh-oh. I think that's also at 11 centimeters. 11 centimeters. Okay. So I'm going to write that here. 11 centimeters. And I think I need to fill it just a little bit more. So we want some water. All right, it's our final one. Are you ready? You ready? Set. Oh, this is pulled tight. My kitty is so excited. I don't know what is up there. Okay, ready, set, go. I'm gonna say 10 and a half for that one. 10 and a half. All right, that's that. And this little tape is not gonna last forever. I am sloshing everywhere. Mr. Sylvie just moved his phone. There's gotta be a better way for me to pour that. There, that's better, huh? My first day pouring. So that's a fun little experiment. I think it's a really cool thing because it really gives you an idea that the higher the tide is, the more water pressure that is going to come through. And I'm going to grab a dishcloth real quick so I can wipe down. This table is wood and it doesn't like water sitting on it. It's not awful, but if you leave it on there too long, it starts to get like white spots on it. So I just try to keep it dry. Okay. All right, so let's go ahead and do a scientific drawing of our experiment that we just did. And so if you look right here on your page, go ahead and do a scientific drawing of the experiment that we just did. And I'm not going to do one because I don't want you to just copy mine. I want it to be yours. I do think you should label like water, pan, measuring tape, things like that. So go ahead and draw a picture of what we just did. Pause the program if you need more time. Okay, here are our questions here, and like you'll see it got a little wet, and that's okay. So let's go ahead and do this first one. Which amount of water made the water pour the furthest? Pause the program to answer that question. Okay, so I think we can all agree based on our data, and I didn't write it the last one, based on our data that we have here, I think we can all agree that the water at the 20 centimeter mark poured the furthest, and by quite a bit, I would say. Okay, so I would put the water at the 20 centimeter mark poured the furthest. Number 2, why do you think this amount went further than the others? Pause the program and look, it says, why do you think? This means it's a think in your head. You get to answer that question, okay? So pause the program to answer this one. Okay, if Miss Sylvia were to answer this on this page, I would say that there was more, since there was more water, there was more pressure, and the gravity was pulling it down harder, something like that. And so it poured out further. I would say something along that. There's more water, there's more pressure, and it came out faster, something like that. Okay, number 3, were your 3 trials different from each other? Why do you think they were different or the same? Go ahead and pause the program and answer that question. Okay, so we did 3 trials of each one, and we can look and see, yeah, they're different. And why do we think that? Well, sometimes the measuring tape would fall a little bit. Sometimes it's not an exact, precise way to measure. Water pouring out is kind of a difficult thing to measure. And so our measurements are just a little bit different each time. And that's okay. And that's why it's important for us to have 3 different trials so that we can see consistently this one was less than this one. Consistently this one was less than this one. And so if you don't have your 3 trials, you know, one of them could just have been an accident or a mistake. Maybe your measuring tape got all bunched up for that one or something like that. So it's really important to have 3 different trials so that you can see patterns that start to happen. We see the pattern. This one is smaller than this one. This one is smaller than this one. And so that's how we can make conclusions based on our data. Okay, here we go. Was your hypothesis right? Why or why not? So this one's tricky because my hypothesis, I mean, I've done this before, so it's kind of tricky for me to make a hypothesis. But you could say my hypothesis was not right because 15 centimeters did not pour the furthest. Or my hypothesis was right because 20 centimeters did pour the furthest. Okay, how does this relate? Oh, pause the program if you need to write this out. I don't think I gave you all a chance to do that. I'm sorry. Okay. Number 5, how does this relate to tidal energy? Go ahead and pause the program to answer this question. Okay, so we know that as, and we'll go back, let me, have all kinds of papers here. Okay, if we go back to this, we know that the high tide right here, this high tide pours through here, and the higher the tide is, the faster it's gonna pour through here, the more this is gonna spin, and the more electricity it's gonna create, okay? And so something along the lines of how does this relate to tidal energy? The higher the tide, the faster the turbine is going to spin. And the more the higher the tide, the more electricity you're going to get coming out of the generator that is there. Okay, something along those lines. Okay, go ahead and pause the program and glue these into your notebook. Go ahead and glue these pages in. Pause the program to glue. Okay, now I have an engineering challenge for you. Okay, so here's your challenge. Because tidal energy and dams are very similar, we are going to make a dam using a pan. And I told your parents that if you wanted to use something from your kitchen, that's fine. It's just we're gonna put some dirt in there. So I use these kind of disposable pans and I reuse them again and again for class, so it makes sense for me to have these. So you need a pan. You need about 3 cups of sand, a pan and sand, and you can use up to 20 popsicle sticks. And your engineering challenge, should have this sheet as well. Your engineering challenge is how can you make a dam out of sand and popsicle sticks? Now, you may have soil, because that was the other option that I gave your parents. And sometimes you can just, you know, this is like if you use potting soil, you can just put it back in the plant with the plants if you need to, okay? So, so a pan, popsicle sticks, and dirt, sand or soil is fine. And so the first step that we're gonna do is imagine and plan. Before we get much further, I'm gonna tell you how we're gonna test this challenge, because you should know that when we go ahead and make it. You have to make your dam in the center of the pan. We will then add 2 cups of water to one side, and we will elevate it about 5 centimeters in the air, okay? And we're gonna see how much water you can prevent from going to the other side of the pan, okay? So sand and up to 20 popsicle sticks. So the first thing we're gonna do is imagine and plan. And so go ahead and pause the program to imagine and plan how you are going to make your dam. And I'm gonna do mine now too. Okay. All right, so I can show you mine. No, I don't want to show you mine. I want you to do your own. Don't look at mine. Don't look at mine. Okay, so now is your chance to create. So go ahead and pause the program to create yours, and I'm going to create mine. You want to show it? Wait, yeah, go ahead. You can show me. Okay. So you have probably already created yours since you paused your program. And now Miss Sylvie is creating hers. And you can see. And I think what I'm going to do is I'm actually going to push these, I don't know. These should sort of be like embedded in here a little bit, I think. That saying some structure. I don't know. What do we think, Mr. Sylvie? Yeah? Because I kind of think of like a log cabin. You know, you have your logs, and in the middle of your logs, you have like the dirt that kind of holds it. I don't know. What do y'all think? And then I'm gonna kind of press these into the side here a little bit. Where the water is gonna get around that. Let's see. Maybe like that. A little. You don't have to use them all, but okay. Now, if you were in class, I would say, which side would you like me to put the water on? And then you would tell me which side. And I have sand everywhere. I'm gonna have to sweep my floors, and I'm sure you guys do at your house too. Okay, so I have my 2 cups of water, and I'm going to put them here, put it here, and oh, my popsicle stick's floated, and I'm gonna lift it 5 centimeters. Hey, I'm actually pretty proud of that. Now, if I look, I can see it's going out that side, right? I'm pretty proud of that. Now, just doing some evaluation, this one was much closer to the edge here. So, so test and evaluate. I'm gonna do my picture here. And what ended up happening is I had my dam here and the water flowed that way on the side. And then of course, these guys here, down below, I don't think they did anything. They just kind of floated around. So I think if I were to do this again, I would put more closer to, I would make sure my edges were a little bit more solid. You know, make sure that there was a popsicle stick right there at the edge. Okay? And I wouldn't bother with the ones down there because I don't feel like they did anything at all. So, all right, boys and girls, go ahead and glue this into your notebook. I hope that your dam was successful. If you would like to, you can always have your mom take a picture and email it to me. I would love to see how your dam turned out. And this is just kind of a fun thing to do. And I've seen people use like aluminum foil and bricks. They go outside and they use bricks and they try this outside. So rocks, there's all kinds of things that you can do it out of, but I just thought this would probably be the easiest thing to use in your home, except for the sand everywhere. It's just, it's not terribly messy, right? It's not terribly messy. Okay, and the last thing that I have your homework. It is this page. The Magda School Bus Goes to Muscle Beach. These should be on Netflix or YouTube. They're pretty easy to find. And this is really neat because they talk about the tides on there and the different animals that live in the tides. And I know anytime that we can learn about animals, it just makes things a little more exciting. So go ahead and answer these questions the best you can. I know sometimes it's hard, like you miss some of the questions, and that's okay. But this is just kind of a way to kind of keep you focused on the science of the show a little bit. So fold this in half and glue it into your notebook, and then you'll have it in there. And then when you watch the Magda School Bus, you can answer your questions, okay? So that is all I have for you. The last thing that we're gonna do is we are gonna read The Foolish Tortoise. And I think I'm gonna read it as part of this video because I'm just gonna do that. Okay, so here we go. I'm gonna read now. And this little guy here, his shell is an amazing resource. And it takes them a little while to realize that. So the pictures are by Eric Carle, and he does just really cool paint, and I think some of this is like paper pieces he uses. He did, you know, the Very Hungry Caterpillar, the Very Grouchy Ladybug. He does that whole series, but it wasn't written by him. It was written by Richard Buckley. Okay, The Foolish Tortoise by Richard Buckley, illustrated by Eric Carle. A tortoise, tired of being slow, impatient to get up and go, took off his large and heavy shell and left it lying where it fell. Hooray, he cried, now I've been freed. I'll see the world at double speed. Though faster, he was not express, and his protection was far less. So when he heard a hornet's drone, the tortoise crept beneath a stone. A hungry bird came swooping past. He looked so fierce and flew so fast. The tortoise hid behind some trees and felt quite weak behind the knees. He's nervous, like he's scared right there. It's a fierce bird. And hornets, it's like wasps, right? We don't like that. They sting. I don't feel safe. There's too much risk. If only I could be more brisk. He headed for the riverbed. A fish swam up. The tortoise fled. It's a pretty big fish, if you ask me. He looks a little scared of that fish. Along his way our hero went and almost had an accident. A snake with open jaws slid near. The tortoise backed away in fear. A hare, a hound, a horse raced by. So rapidly they seemed to fly. The tortoise gasped, sat goggle-eyed. I'll never be that quick, he sighed. My brain wants to say Google, but it's not Google, it's goggle. He wandered on. The sun rose high. I wish I had more shade, he cried. A sudden thunderstorm swept in and soaked the tortoise to the skin. Now he's all wet. The wind rose up, and soon the breeze was bending branches in the trees. The tortoise shivered. Now I'm cold. I wish I hadn't been so bold. I think I've lost the urge to roam. I think it's time that I went home. Without my shell, I don't feel right. So when his shell came into sight, he climbed back in and said, good night. So now he appreciates his resource, his shell. He's very grateful for it, right? All right, boys and girls, that's all I had for you this week. You have a wonderful week, and I will see you on YouTube next week. Bye.